For my chemistry students, since we're in the middle of equilibrium, my daughter and I had done the fish tank demonstration to show you things on a big scale, but now I'm going to show you things with an actual chemical reaction. And you can use this one for reaction speed, but you can also use it to show equilibrium. And that's what I'm going to do here. And make one small adjustment. So this is an experiment or demonstration called a blue bottle. And it's pretty simple to do. You use an indicator called methylene blue, which is used for microscope slides in biology labs. But some of you, if you've ever had an aquarium before, it's also used in fish tanks. So this is something that's easy to come by. And it's an indicator, and it changes colors between blue and going clear, depending on if it's being oxidized or reduced. And if you're an AP Chem, we'll talk about that next year. But methylene blue, if in the presence of a lot of extra oxygen, will go clear. But then if it's able to react with something different, in this case, dextrose and sodium hydroxide will turn back to blue. And so you can go back and forth and back and forth and back and forth. So we're going to do a demonstration that shows what will happen with equilibrium when you've got a bottle with methylene blue and it's in water with a lot of extra glucose and some sodium hydroxide. And where does the oxygen come from? Well, it comes from the air. And when it's trapped in the bottle, it's got a finite amount of oxygen. And when you shake up a bottle, oxygen temporarily gets dissolved into solution, and then it slowly bubbles its way out. Well, how do you get it back in there? Well, you shake it back up, and you start the whole cycle over again. So you can tip this equilibrium about what color the methylene blue is going to be, depending on, is there a lot of oxygen in solution, or is there not? So we're going to mess with this, and you're going to see what happens when you give it a lot of extra sugar, some extra sodium hydroxide, and then what happens when you change the temperature of the solution, and how the equilibrium goes back and forth, and whether that happens slowly or quickly. So all those things that were in my PDF file for you guys to look at, and all of those things that were online for you guys to look at, we're now going to do for you live and in person. So come on back. We're going to have some fun with this one, and hopefully this one will be kind of interesting for you. Stick around.